Okay, we're going to continue with H10 derivatives, part 2. So we just finished going over questions 1 through 4. So now we're going to start on question number 5. Okay, question number 5 says we've got this function in the form of f of t equals p to the power of q cosine rt. Okay, and here is this graph we've got. Points A and B have coordinates 1, 6.5 and 5.2, 0.2 on the line. Point A is a local maximum, point B is a local minimum. Find the values of P, Q, and R. Okay, so the first thing I did was I said, okay, so here's my function that they just gave me, and I used this first point at 0, 6.5. So I plug in 6.5 in for y. I plug in 0 in for t. Cosine 0, we just talked about a minute ago. Cosine 0 at 0 degrees or radians, we have 1. So I'm replacing cosine 0 with 1. So now I have p times e to the q times 1. Okay. All right. The next thing I'm going to do is I'm going to put in 5.2 in for x and 0.2 in for y. So I've put in 0.2 in for y right here. I've put in 5.2 in for x. And now I've got this equation right here. And so the next step is I'm going to say, okay, at this point right here, we know that, oh wait, we're not going to that part yet. That doesn't make sense if I talk about that yet. Okay, so let's look at this point right here. We know that this is a minimum, right? So let's take the derivative of my function here. So the derivative of this function is going to give me negative p q r sine t rt times e to the power of q cosine rt. Okay, so there is my derivative. So the maximum occurs when the derivative is 0. So if I make sine of rt equal to 0, then I'm going to find my maximum. So that our sine is equal to 0 when sine is equal to 0 when theta is 0 and when theta is equal to pi. So if theta is equal to 0, well, we already did that up here. So when theta is equal to pi, then I can plug in that means this right here, the r times 0.52, that has to be equal to pi in order for sine of pi to be equal to 0. I want to think about that for a second. So we want this r times 5.2 to be equal to pi. Okay, so then I get r times 5.2 equals pi, and so I can divide both sides by 5.2, and now I've got my r value now. Okay, so let's look at this other point here. We've got 0.2 equals p times e to the q cosine pi. So pi, cosine pi, we know is equal to 0, right? So if that's equal to, sorry, that's not correct. Cosine of pi is equal to -1. So if cosine pi is equal to -1, then we're going to have 0.2 equals p times e to the -q. Okay, so then, what the heck did I do here? P times e to the -q. We know p times e to the -q is this. And p to the q is this over here. Okay. And p to the q we know is equal to 6.5. So now I can solve for p, because e to the power of -q times e to the q is going to give me e to the -q times e to the q gives me e to the -q and plus q. The power is going to be like that, which gives me e to the 0, and anything to the 0 is 1. So that's why the e to anything q goes away, because that's equal to 1. Okay. So now I end up with p squared equals this times this, and then I end up with p equaling 1.14. Okay, so now I'm going to substitute 1.14 in place here. So I've got into this first equation right here. So we have got 6.5 p times e to the q. I'm replacing p with 1.14, and then, right, I'm replacing p with 1.14, and now I can divide both sides by 1.14 and I get this. And so then I can convert this exponential graph to log, and I would get natural log of 5.7 is going to be equal to q. Okay, and so there is q. Okay, let's do question number 6 now. Okay, so question number 6 starts off with this function like here. So to make things a little simpler, I did distributive property with the x over 10, okay, to get this. Okay, remember, at any time hit pause. Okay, so the first part of the question says find an expression for the derivative. So the derivative of this with respect to x, the x is just going to disappear, and then we get this. And then the derivative of this, the x is going to decrease by power. It's going to become x squared, and this 3 gets multiplied to the front coefficient, and then we're going to end up with 9x squared over 1,000. Okay. Okay. So question 2 says, hence, find the maximum c in terms of k, and give your answer in this form. Okay, so to find the maximum value, I need to take this derivative and make it equal to 0. So I'm replacing this with 0, and I've got k squared over 10 minus 9x squared over 1,000. Okay, so to get the denominator to go away, I multiply both sides of the equation by 1,000, and then this sort of cancels out, and then I end up with 9x squared equals, and then this 10 cancels out with that, and I end up with 100k squared. And now I can divide both sides by, we're solving for x, right? Sorry. So I divide both sides by 9. Okay, and then I take the square root of this, and fortunately this is easy to take the square root. I end up with 10k over 3. But we're not done with part B. Part B says we find the maximum value of c when k, in terms of k. So now I've found out the x value is 10k over 3. And so I'm going to substitute 10k over 3 into the original function. So my original function is up here, k squared x over 10 minus 3x cubed over 1,000. So I'm replacing x with this. Okay, so I just rewrote this earlier equation, and I'm replacing x with the 10k over 3. Okay, hit pause if you need to copy this down. Okay, so this 10 and that 10 cancels out, and I end up with k cubed over 3 here. This 10k over 3 becomes this 10k becomes 1,000. K, we have k cubed, and the 3 cubed becomes 27. So this is a 7, 27. Okay, and then so we've got k cubed over 3 minus 3k cubed over 27. So this second fraction here simplifies to k cubed over 9. So let's change this, the first fraction here, to get a common denominator. So then I get 3k cubed over 9. That's this. Minus, and then this one didn't change, k cubed over 9. And then I end up with 2k squared over 9. Okay, so that's the answer for question B. Question C says find the value of k. So to find the value of k, okay, so here is our original function, right? From here. Here is the original function. Okay, so to find the value of k, we know that, they've told you when the profit is 426, we know x is 20 liters of coffee. So I'm going to replace x with 20, and I'm going to replace c with 426. And then that's going to help me figure out an answer for k. Okay, so I've got 426 equals k squared times 20 over 10, and then 3 times 20 cubed over 1,000. Okay, well 20 cubed is 800, and 20 goes into 10 twice, right? So then I say, okay, well 8,000 divided by 1,000, that's going to give me 8, and 8 times 3 is 24. So now we've got this, and then we can add 24 on both sides, and we get this, and divide both sides by 2. I get that, and take the square root of k, everything, and we get 15. Okay. So next, the question says, use the model to find how much coffee should be made each morning to maximize profit. So we know the maximum is 2k squared over 9, right? So that's what we just figured out from part B. So, but I'm going to replace k with 15 to figure out the maximum profit. So now I've got 2 times 15 squared divided by 9, and then the maximum profit is going to be 50 whatevers. $50. Okay. All right. Question D says, sketch the graph of C against X and label the maximum point and the x-intercepts. Okay. So in order to sketch this, I needed to rearrange the equation. Okay, so before I could sketch this, I had to... So here's the original equation, right? And now we know that k is 15. And so I simplified this with k being 15. Okay. So in order to graph this, I needed to change my window on my graph. Let's type this in. Okay, so I've got 225 x divided by 10 minus 3x cubed divided by 1,000 window x max. Okay, so I've changed the window to what I stated here, graph, and we get something that looks like this. Okay, so then they've asked us to draw this graph and to find and to label the maximum. So so to do that, we do second trace. To find the maximum, I hit 4. And you should be comfortable with left bound, right bound. So I hit enter, go to right bound. I hit enter. It says guess. I hit enter. And then we get 50, 750. And then second trace to find the 0. And I'm going to go way over here. Enter, that's left bound. Now I go to right bound. Enter, guess. And it tells me this point here is 86.6, 0. Okay. And then question E says, what is the maximum number of liters of coffee to make in order to not lose money? So in order to not lose money, if I make less than 86.6 liters, then I'm not going to lose money. Okay, that's question 6. Okay, let's look at question 7. Oh, this is a fun one, skier. Okay, so we've got, this is a function of the derivative. Okay, so has a local maximum and minimums at, and some things are happening at A, E, A, C, and E. And the graph intersects the x-axis at B, D, and F. Okay? So from a derivative graph, we know that where we have maximums and minimums, this is going to give us inflection points. Why is that going to give us an inflection point? Because the second derivative, when the second derivative equals 0, we have inflection points. Right? So when the second derivative equals to 0, we have inflection points. So basically, on this graph, it's when the first derivative has a max or min. So when the first derivative has a max or min, then the slope of this is 0. And in order for the slope of this to be 0, that means the second derivative is going to be 0. Okay, so I know I'm going to have inflection points at those points. So here the slope is going down. So at these blue portions, we have concave down. Because the slope is going down, the slope is negative of the derivative. That means we have concave down on the second derivative graph. Since the slope of the derivative is positive, we have concave up. Okay. What else? Okay. When the first derivative is 0, that means on the original function we're going to have maximums or minimums at B, D, and F. Okay. So identify the x value. So all these things that I just did are going to help me when I want to graph on the next page. But anyways, this was important conversation. So identify the x value of the point where the absolute value of the derivative has the maximum value. So the maximum value is the biggest difference here, which is going to happen at A. Question 2, interpret this point of the given graph. So the interpretation is the skier has the highest speed at A, therefore the largest slope and the steepest point. Okay, now using this information, we know we have inflection points at A, C, and E. A, C, and E. And then we know we have maximums and minimums at B, D, and F. So at B, D, and F, we've got maximums and minimums. And then so between 0 and A, it's concave down. And then we hit the inflection point. So basically what I did was I drew a concave down, looks like a sad face, right? Until I got to A. Okay. Then from A until C, we have concave up and a turning point at B. So from A until C, it's concave up. Notice it's like a happy face. Whee! And at B, we have our turning point. So, and then from C until E, this is all going down, right? Down, down. So we know we have concave down between C and E, so it's going to look like a sad face, and we know we've got a maximum at D, which because it's got concave down on either side. So here we have a maximum at D, and it's concave down, looks like a sad face between C and E. Then lastly, between E and F, this is a minimum because we have a concave up happening, and it's just kind of like a smiley face, and so from here to here we have concave up. Okay, I'm going to let you hit pause and think about this, and you may want to rewatch this to think about how that works. Okay, last one. I'm going to rewrite this. Okay. This is not a piece of cheese, it's a piece of wire. Okay? So we have wire that's equal to 15 centimeters long. And and so this wire, we want to show that R is equal to this. So the total of the wire is 15 centimeters. So so this total is 15. Okay, so let's just hold on a second. I am doing a video. Okay, so we've got all of the lines here add up to 15. So I've got this part right here, this part right here, this part right here. So those are all 1 centimeter long. So I'm going to put a 3 there. Now we've got this line here we don't know the length of. And then down below we don't know the length of that. So we can call that 4R. Okay. And then we've got this portion right here. What is that length going to be? So this length here, if we look at our formula packet, which is somewhere, oh my gosh, looking at my formula packet, this arc length, the length of an arc is r theta. Okay, and we've got 2 of it, so I'm going to say plus 2 r theta. Okay. All right, so now we're trying to show that r is this, right? So I can subtract 3 on both sides. I get 12 equals 4r plus 2r theta. I can factor out the r, and then I get 12 equals, I can factor out a 2 also. Factor out 2, so we have 2r, and then we get 2 plus theta, right, if I factor out the 2r. And now we're going to, we know that 2 goes into 12 6 times. So now I've got 6 equals r times 2 plus theta. And I divide both sides by the thing, and we get r equals 6 over 2 plus theta. Okay, you kind of need to show your steps in order to show. So when you are showing something, you have to show the steps. Otherwise, they won't give you credit for showing. Okay. Question B says, okay, the faces of the frame are covered by paper to enclose the volume. Write an expression for V in terms of theta. So, in order to do this, we know volume is going to be equal to the area of the slice of pie. So it's going to be equal to the sector area times the height. Okay, the sector area times the height. So the area of this surface here times the height. Now the height of this is 1. So we already know this height is 1. Okay. Now the sector area, if we look at our formula sheet, the area of a sector is 1/2 r squared theta. So V equals 1/2 r squared theta. We know this height is 1. Okay. And and now we know that r is this guy right here, right? So now I'm going to substitute that in. So V equals 1/2 times 6 over 2 plus theta squared. And then we've got this theta. I have no more different colors. So anyways, so this r right here is this, right? So 1/2 the yellow thing squared times theta. Okay, and then now we can simplify this a little bit further. We've got V equals 1/2 times 36 over 2 plus theta squared times theta. And I'm just going to go one step further. So 36 divided by 2 is going to give me 18 theta over 2 plus theta squared. We're going to need this form in order to help us do the next part II for finding the derivative. Okay, I think they would accept this answer here for part BI, but we need this form of the answer to do BII. So for part BII, we're trying to find the derivative. So we know V equals 18 theta over 2 plus theta in parentheses squared. All right. So we're going to use the quotient rule. Okay. And so to do the quotient rule, I'm going to let U equal 180 theta. I'm sorry, 18 theta. I'm going to make V equal to 2 plus theta parentheses squared. U prime is going to be equal to 18. V prime is going to be equal to 2 times 2 plus theta. I'm just going to rewrite that. Maybe I won't rewrite that. I'll leave it like that. Okay. So now I'm going to do the quotient rule. So just for those who don't remember the quotient rule, somewhere here. The quotient rule is v times u prime minus u times v prime over v squared. So v times u prime is 2 plus theta parentheses squared times u prime, which is 18, minus u times v prime divided by v squared. Okay, so that's going to simplify to I'm going to leave this as 18 times 2 plus theta squared minus, okay, 2 times 18 is 36 theta times 2 plus theta all over 2 plus theta to the fourth. And then I see a common term, 2 plus theta, 2 plus theta, 2 plus theta. So I'm going to factor out a 2 plus theta in the numerator and the denominator, and then I'm going to get v prime equals 2 plus theta cubed. And then I end up with 18 times 2 plus theta minus, and then that one cancels out, 36 theta. I'm just going to put an arrow here to show the next step. 2 plus theta cubed in the denominator. 18 times 2 is 36. 18 times theta is plus 18 theta, and then minus 36 theta. Okay, 18 theta minus 36 theta is going to give me negative 18 theta. So my final answer here is 36 minus 18 theta over 2 plus theta parentheses cubed. Okay, and that is my answer for BII. Okay, and for III, they want you to make dv d theta equal to 0. Okay, so I'm going to make this equal to 0. So I've got 36 minus 18 theta over 2 plus theta cubed equal to 0. So in order to make that equal to 0, I need to make the numerator equal to 0. Okay, so we're going to make 36 minus 18 theta equal to 0. So I can subtract 8 theta on both sides. I get 36 equals 18 theta, and then divide both sides by 18. And then I get theta equals 2. And that's it. So as I mentioned before, make sure that you hit pause and rewind if you need an extra explanation on anything.